Good evening, everybody. Everybody can hear me? Okay. Good evening, everybody. I hope all of you are in complete health. I think, as I told some students, I think today is last class. Yes, because today is the 10th class, and as you know, the course has 10 classes. Since today is the 10th class, I think today is the last class, and because of this, I'm going to explain the last chapter and discuss more together about topic of statistical process control and solve an exercise for better understanding this topic. So let's have a review on last chapter, statistical process control. If you remember, I told you statistical process control refers to methods which help operation manager to see the process is under control or not. What does it mean? Anybody can remember what does it mean, the statistical process control? What's the meaning of the process is under control or not under control? If anybody wants to discuss, please let me know to pass microphone to him or her. Yes, as Mrs. Mascuda told, the process is under control or not, it means that the products or goods are being produced in one factory should be monitored by operation managers to see is there any defective product or not. On the other word, operation managers should check the products are being produced in high quality or not. If there is a problem in a product, for example, imagine that a factory is producing clothes, dresses, and something like this, but some of the dresses are not producing according to standard, and there are some problems in jeans, t-shirts, or dresses that are being produced. So it shows that somewhere there is a problem. This problem can be sourced from machines. The machine has broken, or or the labor has done a mistake job, or something like this. So that moment, operation manager should stop the process and look for problems to solve it, and it should he or she should prevent the producing more, because of this problem the products are being produced along with defective, and they cannot sell these products to market, since most of them are defective. Yes, these methods and this process is applicable for all factory and manufacturing companies that are producing products. Food industry, in all of the industry, these methods and these concepts can be used and are applicable for all of them. So statistical process control are methods that can help operation manager, and or on the other word, operation manager can use or can apply these methods to check the process or they monitor the process to see whether there is there any problem during the process or not. And if you remember, I would tell you that every hour to every hour or every half an hour to half an hour, it depends on the project and depends on the operation manager's program. The process should be checked, should be monitored. For example, 5 times a day, 3 times a day, operation managers should choose sample from products and go to laboratory and check them and to checking this variable of the sample, for example, the weight, the speed, the height, width, and something like this, and checking and measuring these variables. They can check them with a standard or with the standard that a designer or engineer has produced and has told to operation managers to consider them. So by this brief explanation, we can start the lessons. Statistical process control. In the first slide, as you see, the variability is inherent in every process, natural, common, special, or assignable causes. Okay. As I told you, when the machines are producing, for example, 500 laptop, 500, for example, jeans, dresses, and every product that you can call. Okay, no problem. All of the products are not similar together. When you measure the size, measure the weight, measure the speed, and something like this that should be measured. When you measure them, you will see that for example, all of the 500 or 600 products that have been produced are not similar, and they have a little different, and they have a little variability among these products. This variability can be caused for 2 reasons. One reason can be natural or common, and second reason can be special or assignable. If this variability is natural or common causes, the operation manager cannot do anything because this is natural, and it should be happen, and because all of the machines have a little error in producing, and the performance of the machines are not 100%. Okay, this is natural. But some of the causes, some of the problems is special or assignable. When the causes or when the problems are special and assignable, it shows that there is a problem somewhere. For example, as I told you, the machine has broken, the machine cannot produce very well, or the laborers has done somewhere has done mistake job, and something like this. So operation manager should, when operation managers see the causes are special or assignable, they are obliged to stop or prevent the process and look for the main reason. Statistical process control, as you see, they provide a statistical signal when assignable causes are present. The natural or common cannot be measured or cannot be coped with them. Okay, but the special or assignable causes can be measured and can be uh, determined and can be resolved by engineers or by operation manager. Detect and eliminate assignable causes of variations, as I told you. Okay. Natural variations, as you see, they also called common causes. Natural and common are the same, meaning affect virtually all production processes. Expected amount of variation. This is expected amount. As you see, this is expected amount, and this is out of control. Output measure follow a probability distribution. For any distribution, there is a measure of central tendency and dispersion. If the distribution of outputs falls within acceptable limits, the process is said to be in control. We will be familiarized with these sentences in the future. The distribution of outputs falls within the acceptable limits. As I told you, if you remember, I told you we should calculate the SDL and UDL, upper control limit and lower control limits. They are the allowed border that should be measured and that should be drawn in the graph. And when all of the outputs or from the sampling falls within these limits, we can say the process is in control. Other than the process is not control. Okay. Assignable variation, also called the special causes of variation. Generally, this is some change in the process. Variation that can be traced to a specific reason. This variation can be traced to a specific reason. As I told you, there is a specific reason number that this happened and the products are not according to a standard. The objective is to discover when assignable causes are present, eliminate the bad causes, incorporate the good causes. Control charts. Constructed from historical data. The purpose of control charts is to help distinguish between natural variations and variations due to assignable causes. The most important duty of the operation manager or quality manager in a factory or in a manufacturing company is that they should choose sampling. They cannot check and monitor all of the products, but they can choose a sampling. For example, if the machine is producing 500 products for 500 parts and something like this in 1 hour, in each hour, the quality manager or the operation manager can choose 50 out of these 500 parts and take these 50 parts to a laboratory and test all of these 50. The sampling show that all of the products are in control or not. So the most important is the operation manager can choose the sampling and take the sampling to laboratory and test all of them. The process control, as you remember, I told you that there are 3 diagrams that each of the diagrams shows a situation of the process. In the first one, in the A, if the diagram is like this, it shows that the process is under control. The second one in the B, the process is under control, but it's going to a bad process, and it shows that in the future, in near future, it may go to be uncontrolled. So the operation manager should take care about that. And in the C, these diagrams that are not similar together and they are not the parallel and they have exceeded the limited borders, it shows that this is out of control. Type of data. As I told you, the data can be divided into 2 parts, variable and attribute. Variables can be measured directly by some tools, for example, weight, height, weight, and dips, and something like this can be measured by scale, can be measured by meter, and something like this. So they are variable. But attributes cannot be measured directly, and they should be measured by another method, by some other way. For example, if you want to measure the how much a person is hardworking, the hardworking cannot be measured by a tool. There is no tool in market that we use to directly measure the being hard working of a person. But you can measure it through measuring some items such as the number of the hours that a person allocate to study every day. For example, a person that is studying 9 hours a day is more hardworking than a person is studying 6 hours a day. Okay. For example, by something like this, you can measure the attributes. So attributes cannot be measured directly, but the variable can be measured directly. Contour charts for variables. As I told you, there are some contour charts for variables that can be used by operation managers to to monitor products and monitor process through which see whether process is under control or not. Control chart for variables that have continuous dimensions, weight, speed, length, strength, and something like this. X bar charts and R charts are two controls that this portion of the that can be used by operation managers to do this. These two charts must be used together. Okay. For drawing X bar charts, we should consider some points before that. At first, for all of the charts, two limitations should be calculated: upper control limit, lower control limit, UCL and LCL. UCL can be measured by X bar plus Z multiply sigma X bar, and the lower control limit equal X bar minus Z sigma X bar. For X bar charts, we know sigma here. Okay, for example, the sigma can be given by engineer to operation manager. X is the mean of the sample means or a value set for the process. Z is number of normal standard deviation. Sigma X can be calculated by radical sigma divided by n, that can be defined as a standard deviation of the sampling. Sigma is population standard deviation, and n sample size. Sigma, and Z are the statistical concepts, and no need to you focus on them because they are given to operation managers by engineer, and they can be given based on the accuracy of the job. When the engineer when engineer has a high accuracy, it gives the high sigma, for example 3 or 4, and high sigma and Z to operation managers, and tell to him or her that because of the sensitivity and the product should be high should be produced in high accuracy, and it should be decided, and the error inside it should be very little. Okay, they cannot exceed it from this, for example, this limitation. So the sigma and its X and Z, according to accuracy of the products, can be given to operation managers. N is sample size. X is the mean of the sample means. Mean of the sample means can be height, can be weight. This is the variable. X means the variables that should be measured by operation managers for products. For example, the length of the sleeves in T-shirt. Okay. or can be weight of the product in the food industry, and something like this. Please look at the example here. In the food industry, this example belongs to a food industry, food company that is producing oat flake. Oat flake is a grain flake, and the weight of this oat flake is very important for managers and for engineers, for specialists that specialists who have produced these flakes. They have told the operation managers, you should measure the weight for the flakes, and the weight should be measured every hour or every half an hour, and the weight shouldn't exceed from this amount. Okay, the amount of the weight for sampling have been given to operation manager or quality manager. Okay, in each hour, operation manager select. Yes, oat flake is food, and the weight of the oat flake should be measured. So the X here is weight. Weight is X here. In hour one, operation manager selected 9 cups of the flakes from machines and go to laboratory and measure the weight of these 9 cups of flakes. In the hour one, for example, as you see in the left, the table on left side, please look at this. In sample number, the weight of oat flake. Sample number means the cup. Cup number one in hour one. In hour one, cup number one has the 17 ohms. Ohms is one of the units of weight. Cup number 2 has 13. Cup number 3 has 16. 4, 18, 5, 17, 6, 16, 7, 15, 8, 17, 9, 16. The mean of these 9 cups n equal 9, as you see, n equal 9, because in each hour the 9 cups of tea has been selected. So the n or sample size is 9, because in each hour operation manager choose the 9 cups and measure the mean of these 9 cups. The mean of these 9 cups in hour one is 16.5. 16.5 is the mean. The mean of these 9 cups in the hour one. For example, the 9 o'clock. 1 hour later, in the 10 o'clock, that means hour number 2, operation manager do the same. He or she selects 9 cups again and go to take the laboratory and measure weight of these 9 cups and calculate mean of these 9 cups. So all of the data and all of the results has been written cup, yes, C-U-P, glass, cup. This is a scale. This is a scale for operation manager, cup. In other one, as you see, the mean of the 9 cups has been 16.5. In hour 2, the mean of the 9 cups has been 16.8. In hour 3, 1 hour later, exactly every hour to every 1 hour to 1 hour, operation manager select 9 cups of flakes and take the laboratory, measure the weight and the mean of the 9 cups and write the result. The result in the 12 hour, during the 12 hour, has been written on the table on right side, hour and mean, hour 1, hour 2. The mean in this table are X bar, not X bar bar. Listen carefully. Each mean in each hour is X bar. But if you sum up these 12 numbers these 12 means that has been written on right table on right side and divided by 12, x bar bar can be calculated. X bar bar means the mean of x, mean of, I wrote for you, mean of weight. Look at it, look at the chat, please. Yes, mean of weight. Exactly. So these 12 number should be, because we for drawing X bar chart, we need the X bar bar for all of the projects around the world. This is the standard. We need X bar bar, not X bar. So for calculating X bar bar, we must sum of these 12 number and divide it by 12. Please look at the chat. I'm waiting for you. Okay, so the 12 number in 12 hours has been summed up and then divided by 12, give us X bar bar. X here is weight, because weight is important for operation manager in this industry and in this company. In another company, it can be height, it can be speed. 16.5, 16.5, please look at the left, table left, okay. The 9 cup of oat flakes has been selected by operation manager and take them to laboratory and measure them by a scale. There is a scale in, do you know what is a scale? Scale is can be used, is a tool that can be used for measuring weight. For example, when you go to the fruit store and purchase fruit, fruit seller measure them by a scale. For example, 9 kilogram, 2 kilogram orange, 3 kilogram apple. This is a scale. A scale, a tool, can be used for measuring weight. That is okay. This 9. Okay, the 9 cup of oat flakes can be the weight of 9 cup of oat flakes can be measured by a scale. Okay, can be measured by a scale, and the result has been written table on the right, on the left. Sorry, table on the left. The rest of them are the same, but because of the not having enough space here, we don't write the rest of them. Okay, we write directly the result. We did it only for the other one, For your understanding, the over 2, over 3, over 4 has been measured exactly by over 1. The over 2, over 3, over 4 has been calculated directly. Do you understand? The over 2, over 3, over 4 has been calculated exactly the same as the over 1, but yes, we did only the 1 over 1 to show you how the rest of the number has been calculated. For example, 16.8, 15.5 in over 3. Sixteen point five. Please look at the slide. Please look at the slide on the left. We sum up this 9 number and divide by 9. Yes, yes. Very good, Mr. Elias. Mr. Elias did it. For over 2 also, we did the same. We selected, operation manager selected 9 cup, take them to laboratory, measure the weight, and sum of the 9 number divided by 9. In over 2, the result was 16.8. No, please listen carefully. Don't be confused because it's very easy. It's very easy. Yes, yes. Mr. Elias, please speak.
Good evening. Can you hear me, please?
Yes, I can.
Okay. It's just I would like to give some helping hand to the dear lecturer. You're explaining it very well. I think it's just a matter of our classmates understanding how to take an average number. I mean, well, on the left side, when we read hour 1, in the first hour, the person took 9 cups of flakes or kishmish or whatever you call it. He took 9 cups of that, and in each cup, for example, in the first cup it was 17 grams. In the second cup it was 15 grams. In the third cup it was 16 grams. And then, so like this, he took 9 cups. Then he calculated the average of 1 hour. It became 16.1. It became 16.1 in the first hour only. So this person did the same thing in the second hour, and the average came at 16.8. He also repeated it for the third hour. The average came like 15.5. He continued and did that for 12 hours. He repeated the same thing like the first hour. Well, the average for the rest is not shown here, but this is the same thing like this one. Here it is for 9 hours, but for 9 cups, and also it is the same for the rest. The second hour like that. So because it is not necessary to show it again, it will take a lot of space. So it's already directly giving the average number instead of giving each cup of that. Is that clear?
Yes, it's very good, Mr. Ekman. Exactly. The rest has been not shown here because we have not enough space here. Okay, we had to write directly the result only. But this result has been calculated, has been come exactly like over 1. Only over 1 has been shown for you, for your better understanding. Yes, 16.5 is the average of 9 cup in other one only. Only for yes, only for other one. For other two also has been done exactly the same as other one. Other three also the same, but because of the lack of the enough space here, we couldn't show you. We couldn't show the all of the table over one, over two, over three separately. We wrote directly the result only. Okay. Thank you, Mr. Akman. Mr. Elias. Okay, thank you so much for your cooperation, Mr. Elias. If you get it, we can continue. Okay. Okay. The result of this 12 order has been written on table on the right. Okay, you can see all of them. This means in the table on the right is X bar, not X bar bar. They are X bar because each of them are average of the 9 cup of flakes, oat flakes. Now, if you want to calculate X bar bar, you should sum of these 12 numbers and divide it by 12. So X bar bar can be calculated. X is weight of oat flakes. X here is weight of oat flakes. Okay, so if you sum up these 12 numbers together, 16.5 plus 16.8 plus 15.5 plus 16.5 plus 16.5 plus 16.4, 15.2 plus 16.4. If you sum up these 12 numbers and divide it by 12, exactly, up to 17.8. If you sum up these 12 numbers and divide it by 12, you can calculate X bar bar. X bar bar can be shown by X that come two short line on top of it. You see UCL equal X bar bar plus Z sigma X bar. X bar bar is 16 here. 16. Average of this calculation has become 16, as you see. Please look at the UCL and LCL. In the bottom of the page, UCL equal X bar bar plus Z sigma X bar. 16. X bar bar is 16. We wrote it here directly. Okay, Z and sigma are given to you. No problem for this. Okay, you as the operation manager receive the sigma and Z from, for example, the designer, from the operation manager, from the engineer, and something like this. Z and sigma given to you as operation manager. Don't worry about it and no need to focus on it because they are a statistical concepts. And as I explained for you, they are related to accuracy of the calculation. Z has given to you Z equal 3. Okay, z equal to, and sigma x bar. Sigma x bar can be calculated. Sigma x bar can be calculated sigma x bar calculates the root square of sigma divided by n. Sigma x bar and sigma are different together. We should calculate sigma x bar. Sigma x bar is root square of sigma divided by n. Sigma on the left, please look at the side on the left in the bottom. Sigma equal to 1. It has been given to you. Z is equal to 3, sigma is 1, and sigma x bar is 1 divided by oh, sorry, please let me write again that for you. Sigma x bar equal, I'm writing for you, sigma x bar equal sigma divided by root square of n. Sigma x bar equal to sigma divided by root square of n. N is sample size. Here is 9. Root square of 9, how much is that? 3. Root square of 9 is radical 9. Radical 9 becomes 3 in mathematics. And sigma also is 1. 1 divided by 3 gives you sigma x bar. So as you see, UCL, the upper control limit can be calculated by x bar plus sigma multiply sigma x bar. X bar, as I told you, is 16 here. X bar can be calculated as we should sum of these 12 means divide by 12. If you do it, you will reach this number 16. Plus, Z has been given to you 3 multiply sigma x bar. Sigma x bar can be calculated separately by sigma divided by root square of n. Sigma is 1 divided by root square of 9, that is 3. So it is the 1 divided by 3. 1 divided by 3 has been written inside the parenthesis, as you see. This is sigma x bar. 1 divided by 3 is sigma x bar. Everybody get it? Everybody has problem or not? Everybody can hear me? It's okay? It's clear for all of you? Okay. I explain again. UCL x bar equal, as you see the formula, please, in the bottom. X bar plus plus Z multiply sigma x bar. X bar is 16. Has been calculated, for example, separately, and we haven't right. We haven't write the process of calculation. We wrote directly the result. X bar has been calculated by 16. Z is 3, and sigma X bar can be calculated by sigma divided by root square of 9. Root square of n. N is 9 here. Root square of 9 is 3. So this sigma X bar can be calculated by 1, that is sigma here, divided by radical 9 or root square of 9 is 3 here. The number inside the parenthesis 1 divided by 3 is sigma X bar. I repeat again, sigma X bar and sigma are different together. Sigma X bar can be calculated by sigma divided by root square of n. $16.5 has been calculated by this 9 number. Please look at the table on the left, other one. Please look at the table other one on the left. If you sum up the 17, 13, 16, 18, 17, 16, 15, 17, and 16 again, if you sum up these 9 numbers together and divide by 9, you will reach to this number. The result is 16.5 for other one only. If you sum up these 9 numbers, just the selected 9 come. Okay? Okay. The other result has been written directly on the right. We ignore to write the table for each of other because there was no enough space. Okay, I repeat again. For LCL equal X bar minus Z sigma X bar is 16 minus 3, that 1 divided by 3 is 15 ohms. 17 ohms and 15 ohms. Ohms is the unit of the scale, such as gram, such as kilogram. There is another unit, ohms. UCL and LCL has been calculated like this. So we can calculate the upper limitation and lower limitation. We can calculate. We could calculate the these allowed limitation. Okay. Now we want to draw the graph of X bar, because the UCL and LCL has been calculated, and now we can draw the table. Diagram. The diagram has been composed of 2 axes, vertical axis and horizontal axis. UCL is upper control limitation. LCL, please let me know you. When we calculate UCL and LCL, in fact, we should say that all of the means in each other, all of the means that has been calculated in each other. For example, in other 1 it was the 16.5, in other 2 it was 16.8, other 3 it was 15.5, other 4 the means was 16.5. All of these means should be located in this limitation. At first, we should draw the limitation, lower limitation, the LCL. The vertical axis is the weight, and the horizontal axis is the sample number, or each other. Other 1, other 2, other 3 should be written in the horizontal axis, and the vertical axis is allocated to weight, ohms. Okay. For example, we can calculate LCL now, 15, and also we draw a line that shows the UCL, a straight line and horizontal line that shows the UCL or 17. And also X bar should be drawn. X bar was 16. X bar, sorry. X bar, as you remember, was 16, and also 16 is has been drawn here. We draw a horizontal line that shows the LCL, and also we draw a horizontal line that shows the UCL 17. The bit, and also we should draw the X bar. X bar or mean of the mean, as you see, is the 16 ounce or 16 gram, 16 kilogram, no problem, 15 kilogram, 17 kilogram. When we draw these lines, now we should mark all of the means inside the graph. For example, in other one, what was the mean of the other one? 16.5. Okay, we mark it with blue circle in the other one. In the other two, the weight was the 16.8. We calculated 16.8 has been written by circle blue circle. We should do it and continue by over 3, over 4, over 5 until over 12. We should draw all of the blue circles that shows the mean of each one of them. In the okay, we mark all of the means inside the diagram. In the other one, I repeat again. Horizontal axis was the sample number, and vertical was the weight, was the ounce, gram, kilogram, and something like this. No problem. But here we call it ounce. Okay. The UCL and LCL had been calculated, and we show it was by a colored area. We color this. This is the limitation. We calculate it, UCL and LCL, and we color it. We paint it, and as you see. If you remember, the sample number 10, sample number 11, and sample number 12 has the means outside this color area or this allowed limitation. Number 10, number 11, and number 12. Please look at the blue circle. The number 10, 11, and 12 has exceeded this colored area. So this process is not under control. This is the reason that why we should calculate this UCL and FCL. At first, we should calculate the upper control limit, the maximum limitation for weight, for the gram or for the ounce here. We should calculate the LCL or minimum. When we calculate the upper and lower control limitation, we should draw all of the put all of the means that has been calculated in each other inside this diagram and see is there any point, is there any sample is out of this limitation control or not. If there is one point, even one point was outside this limitation, we should say the process is not under control. Get it now? It's very easy. Exactly. Exactly. Okay. Um, if you need, do you understand? If you don't understand somewhere, please let me know. We have calculated the places of dot. Yes, yes, exactly. Average of each over is dots. Exactly. For example, in the please look at the number one. Sample number one was the 16.5. Sample in over two means was 16.8. These numbers are dot, blue dot. 16.5, 16.8, 15.5, 16.5, 16.5. These numbers are dot in this year. Um, it has been drawn not very accurate, okay, because the graph has been drawn as schematic. For example, we draw a line that shows this is the 15. We draw a line that shows the 17. As I told you, the axis, the vertical axis is uh, ounce, is the ounce or the or weight, and the horizontal axis is the sample number. Sample number was the average was the, for example, 16.5. It you see the blue dot is a little is above the 16. 16 is the mean, the equal bar that has been written here. Sample number 2 is the 16.8. 16.8 has been drawn near to 17 line. Okay, everybody has. It's okay for everybody. Okay, please let me explain again. Okay, I explain again and everything. As I told you, here is a company that is producing oat flakes. Oat flakes is a name of food, okay? Then the company wants to control this. When the company wants to control the product, the weight for this product is important. Here, the weight is important, okay? So the weight should be measured each hour by operation manager because it shouldn't exceed a specific number, a specific amount, or it should not be less than a specific amount. So the company, the operation manager or quality manager is going to measure this weight to see the machines are producing according to program or not. In 1 hour, so operation manager should select sampling. In each sampling, he or she decides to select 9 cups of the flakes and take the laboratory to measure the weight of each cup. In hour one, operation manager select 9 cups of oat flakes and take them to a laboratory and measure the weight of each cup. Cup number 1, the weight was 17 in hour 1. Cup number 2, the weight was 13. Cup number 3 was 16. Cup number 4 was 18. 5 was 17. 6 was 16. Until 9 was 16 again. You see the result of the hour 1 on the right in the table. Sample number for each cup and its and weight of each cup. In hour 2, operation manager do exactly the same as hour 1. But I didn't write for you the result of hour 2. I wrote directly the result of these means of 9 cups, 16.8 for you. In the other 3, operation manager repeat it and continue it exactly the same. And exactly the same, he or she selected 9 cups again, take them to laboratory, measure this 9 cups of tea, and measure the mean of this 9 cups of tea, and write the result. The result of the 12 number has been written for you on table on the right. As you see, hour 1 has been written for you in top, hour and mean. Hour 2, the mean was 16.8. Hour 3, mean was 15.5. Hour 4, mean was 16.5 until 12. As I told you, operation managers should select the sampling to check the process is under control or not. The variable should be checked here is weight. The unit of weight here that has been used is ounce. It can be gram, it can be kilogram, and something like this. The weight is very important because the weight of the oat flakes that are producing by this machine should not be less than amount of a specific amount and should not exceed a maximum number or maximum specific amount. In order to monitor this, operation manager should use the methods that help him or her to see the process is under control or not. The control charts are the best tools that can be used by operation manager. One of the control charts is the X-bar chart. The X-bar chart is the name of this control chart, and it's recognized by X-bar chart around the world, everywhere in the world. If you go everywhere and tell the operation manager X bar chart, he or she understands what it means, because this is the name of the chart. X bar chart. Why X bar chart? X is the variable that should be measured. Here, the variable or X is weight, ohms. In order to draw the chart, at first we need to calculate the upper control limitation, or UCL. UCL is the brief for upper control limitation, and LCL, lower control limitation. Upper control limitation is the maximum number, and lower control limitation is the minimum. All of the means that has been calculated must be between these two numbers, maximum or UCL and minimum or LCL. If all of the means was between this UCL and LCL, we can say the process is under control. Other than the process is not under control. How UCL and LCL should be calculated? As you remember, I told you UCL has a formula. The formula is the X bar plus Z sigma X bar, and LCL equal X bar minus Z sigma X bar. X bar is mean of the sample. Mean of two mean follow each other. We have calculated mean for 9 cups in each hour. 16.5, 16.8, 15.5, 16.5, and until 12. Okay, X bar means mean of mean. The mean for X bar has been calculated and has been written in table in the top of the slide. Each hour has its own mean. If you sum of these 12 means and divide it by 12, X bar can be calculated. If you do it now, and if you see the 16.5 plus 16.8, 15.5 plus 16.5, 16.5, if you sum up these 12 numbers and divide by 12, you can calculate mean of means, or X bar. Here the result is 16. I wrote it directly here. Z has been given to you 3. Sigma X bar is different with sigma. Sigma X bar can be calculated by sigma divided by root square of n. Sigma is here 1. 1 divided by root square of 9, because n is 9 here. The sample size is 9. Root square of 9 is 3. 1 divided by 3 gives you sigma X bar. Multiply Z, that is 6, plus X bar can give you UCL, or upper control limitation, or maximum number that this flex can have. LCL, or minimum control limitation, is the minimum weight that all of the samples in each hour can be had. Sigma and Z can be given to you by engineer, by designer, or by quality manager, and something like this. They are the statistical concept, and no need to focus on it. They are given to you. Okay. Maximum number and minimum number have been calculated here, 17 and 15. So the weight of 15 ohms and 17 ohms. So the means of these 9 cups in each hour should be more than 17 and should not less than 15. All of the means in each hour should be between 15 and 17 ohms. But if you see the table again here, number 10 is 14.8. This is less than 15. The mean of our number 10 is less than 15. Number 11 is 15.2. Sorry, 14. 14.2. This is less than 15 because the minimum we calculated the minimum must be 15, 1.5, and 12. 12 is 17.3. It's more than 17. We calculate UCL and we told you it shouldn't be more than 17. But three numbers are not in our limitation. Okay. Also from this table you can say this process is not under control because we are three number in this table, in the other number 10, other number 11, and other number 12. Other 10 is 14.8, 11 is 14.2, and 12 is 17.3. There are three numbers that are not in this limitation. Limitation should be between 15 and 17, minimum 15, maximum 17. Now, geometrically, we can show it on the diagram, this table over and table mean. Table over and table mean on the right can be shown as a diagram, exactly like this. This diagram is exactly the data of the table each other and the mean of each other. At first, we should select the 15 and 17. If you show each dot on this diagram, if you draw this diagram and show each blue dot on this diagram, you can see three blue, the number 10, number 11, and number 12 are not inside this colored area. Colored area is the limitation area because they are between 15 and 17. These three numbers have followed this limitation, so the process is not controlled. This diagram is the geometry showing off this table exactly. This table and this diagram exactly are the same, but we show it on the diagram, the table. Horizon axis, horizon 1, 2, 3, 4, 5, 6. Do you see in the number? It is the sample number, and the vertical is the mean or is the weight, mean of each other. Sample number and over is the same. Over 1, over 2, over 3. Over 1 was the 16.5. We show it on a blue dot in the diagram. Number 2 the same, number 3 the same. So at first we should calculate the limitation, upper control limitation and lower control limitation, because these two numbers, lower UCL and LCL, upper and lower, or maximum and minimum, can tell operation manager the process is under control or not. After calculating this, operation manager considers all of the means and check the all of the mean is between these two numbers, maximum and minimum or not. If each of the means or each of the weight, each of the speed, each of the length, and every variable that should be calculated is both of these limitations, the process is not under control. I think all of you get it now, huh? The explanation was good. Okay, thank you so much. There are different methods. It was the X-bar chart, but X-bar chart has two methods. X bar chart. It was the method that we know the sigma. Sigma was 1. Okay, we know the sigma. But there is another method, there is another approach that we don't know sigma. Here is. For X bar chart, I wrote in the blue line. Please read the blue. For X bar chart, when we don't know sigma, when the sigma is not is vague, when the sigma is not clear, is not known for us. Okay, we should use another formula in X bar chart. This is the second method of X bar chart. This is X bar chart, okay, but this is the second method because we don't know the sigma. When we don't know sigma, we use this formula: X bar plus A and these two R bar yeah. X bar plus A2, and this is very easy because A2 is control chart factor found in table. There is a standard table that you can use it to calculate A2. A2 can be R bar is the range, average range of the sample. The range means the range is the minimum and maximum number in each hour or in each sampling. For example, if you see hour one, we selected 9 cup. Okay, we selected nine cup. How much is the minimum number in the hour one? How much is the minimum weight in hour one only? In this table on the right. How much is the minimum number? No. On hour one only. Between among the 9 cup in hour one in table on the right. Among these 9 cup, among these 9 cups in hour one only. How much is the minimum weight? It's 13. In sample number 2. No. Look at the table now on the right, not on the left. Sorry, on the left. Sorry. So sorry. Table on the left. In hour one, only hour one. Please look at the result of hour one. Sample hour one. There were 9 cup. Okay. In hour one, we had 9 cup. In 9 cup in hour one, how much is the minimum weight? Yeah, very good. Osman Safi told me. 13 in the sample number 2. Sample number 2 in hour one only. Please look at the table on the left, not table on the right. Minimum, not mean. Minimum number in hour one only. In the weight of outflake in hour one. Yes, 30. And how much is the maximum in hour one? 18. Very good. Maximum is 18 and minimum is 13. The range, so it's very clear in the hour one. In the table hour one, only a table hour one on the left. Please look at the weight of outflakes in hour one. How much is the maximum number in this 9 number? There are 9 cup or 9 number in the hour one. Yes, the maximum number is 18 and minimum number is 13. Okay. When the maximum number in hour one is 18 and when the minimum number in hour one is 13, the difference between 18 and 13 is 5. 18 minus 13 means 5. This 5 is the range. It's called the range in hour one. Okay. the maximum number in each hour minus the minimum hour in each hour give you the range in that hour. This is the meaning of the range. Okay, so in each sampling or in each hour, when you calculate the maximum and when you calculate the minimum and you minus them, this difference give you the range. Range means the maximum minus minimum in each sampling or in each hour. We can calculate only we can know only range for hour 1 because only the result of hour 1 has been given to you. For other hours, we cannot do this because we don't use the result of each hour. Only the other one but the meaning is the same. The concept is the same for all of the hours. Okay, this is the concept of the range. So range means in each hour or in each sampling, how much is the difference between maximum and minimum. This is the range. When you calculate range for each hour and sum of them and divide it by 12, yes, A2 is defined as control chart factor. Control chart factor give you through the table, this table. With regard to sample size, with regard to your sample size, the mean factor is, this is the standard as has been calculated in by peer-reviewed researcher. Now you can use this standard table for A2. Okay, please don't look at the upper range and lower range. Don't look at them. Only look at the mean factor or A2. A and this 2 have given to you through this table. Sample size 2, 3. For example, sample size n in this example is 9, so A2 is 0.337. Okay. Okay. I gave you an example for using this formula. Okay. Imagine X bar was 12 ohms. Imagine, okay. This figure has been given to you just as an example. It's not related. It's not related to previous example. Okay, it's not related. I just give you only this number to use as formula. Only this. Okay. Average range I have calculated for you. R bar is 0.25 and sample size is 5 here. When sample size this is not related to previous example. Okay, this is the separate example. Everything has been given to you directly to use it in this formula because this is very easy. When n is 5, sample size is 5. How much is the A2 mean factor? I gave you n equal is 5 in this example, in your example. Very good. 0.557. Okay. Everybody understand? I give you in this new example n equal 5. Sample size is 5 or n is 5. So the A2 from this table is 0.577. Yes, very good. So UCL or upper control limitation or maximum number can be calculated by X bar is 12. I give you in the top plus A2 is 0.577. R bar has been given to you 0.25. As I told you, R or range should be calculated in each hour. In each hour, range can be calculated. Range is difference between maximum and minimum in each hour. As I told you, for example, in hour 1, maximum number was 18, minimum number was 13. The difference between 18 and 13 is 5. If you calculate it the same, for all of the other, for example, other one, the range was, yes, very good, 5. For example, in other 2, the range was 6. In other 3, the range was 5. The other 4, the R bar is the mean of this range. If you sum of this range are in all 12 number, for example, and divided it by 12, you can calculate R bar. R bar is the mean of this range, and each range in each other is the maximum minus minimum. I give you directly here, no need to calculate. I give you, this is a new example. This is a new example here, as you see. X bar plus A2. X bar has been given to you, for example, 12. A2, with regard to sample size or n is 5, you can find it from table, and R bar is 0.25. You can calculate UCL is 12.144, and LCL is 11.857. All of the means must not more than 12.144 and must not less than 11.857. If all of the means in each other where between these two numbers, the process is under control. Other than the process is not under control. Yes, very good. This is a new formula. This formula is when you don't know sigma. For example, sigma is not known for you. No, R bar should be calculated by yourself. The calculation is it's enough that R bar means the maximum minus minimum in each sampling or in each other. Range, it is the range. Range means the difference between maximum and minimum. Yeah, very good. Yes, exactly. Maximum minus minimum is range in each other or in each sampling. Because each sampling, operation manager selected 9 cup of the flake. Okay. Every cup has its own weight. When he measured the weight of all 9 cups, the maximum weight of cup minus minimum weight of cup in that sampling is the range. You should calculate the range for each other. So for example, we will have 12 range because we had the 12, for example, the previous example. In previous example, we had 12 other, or we had 12 sampling. We had 12, yes, we had 12 sampling. Each sampling or each other has its own range. Okay. Yes, I give you directly. This is a new example. I give you directly the X bar. I told you the X bar is 12 ohms. No need to calculate and no need to know that. We want to be familiar with it only the formula. But X bar, as you see, can be calculated as I told you. Exactly the same, exactly the previous chapter, previous example. Okay, I think today is enough because I'm sure you are tired now, and in my opinion, it's better I give you the new charts next week. It's better for you. I think we have it 1 week later. Okay, the next week is the last week. I think today was last week, but the next week is last week, as I asked the institution. No, we have one more. We have one more classes next week, and in next week we can solve a new exercise together about the X bar chart, and I give you the R chart, another chart. Yes, we have one more classes next week, I think. In next week, we solved a new exercise together about X chart, and after that, I give you R chart. I think it's better I don't teach you R chart today because of two reasons. We have not enough time now. This is one reason, and another reason is you are tired now, and it's better you focus on each chart to better understand this very good. And after that, we go. Okay, do you agree with me? Do you agree to do this? Okay. All of you have this slide. Okay, I have sent you this slide for all of you. Anybody has? Is there anybody to not have this slide? I have sent to all of you. No, 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 no. This I have sent to you the last week, I think. Last week I have sent this. All of you have this PowerPoint now. Yes. Okay. Very good. So please study this PowerPoint and also study the textbook together, and prepare yourself for next week. And if you have any question, you can send to me email, and also we can discuss more next week together. But I think most of you have understand today, yes, because I try to expand each of sentence for you, and I try to explain basically from basic until end. It was very, this is very interesting and very useful. Okay. Okay. I hope all of you are all of you have a nice night, and now I know you all of you are tired, and you can go and rest and please study this chapter by this PowerPoint and by textbook. And if you have any questions, don't hesitate. Send me email, and we will discuss more the next week together about X bar chart, and I give you new lessons R chart. Okay. Have a nice time and have a nice night, everybody. I hope everybody have a nice time with your family. Yes. Have a nice Yalda together beside your family. Okay. Good night and goodbye, everybody.